Next test is next Friday. It'll be 2 FRQ questions not from the packet, but from the subject matter covered in the packet from this week and next week. And we'll just continue kind of the pattern of I'll do 2 and assign 2, I'll do 2 and assign 2. And then that way you've got some homework, not too much. If you need to do more, there's tons of resources out there. The AP Classroom has videos. College Board puts out videos, review videos. Like there's tons and tons of stuff out there for you to look at, review, whatever you need to do to get ready for May the 4th. So that's coming up quick. All right, yesterday we did accumulating rates of change. Today we're going to do a couple things. We'll do 2 of these. So we'll first do the free response questions. I'll do 2 and assign 2, but then we'll do our multiple choice thing as well today. So look at the packet, and let's look at number 1. Yes. All right, so looking at review topic 5, differential equations. We'll do 2 of these, and then we'll work on the, it's a little out of order. Then we'll do the multiple choice that's differential equations. This first one we're going to do, number 1, from 2017. This one was on AB and BC. And this one has, among calculus teachers and in the AP calculus community, this one is one of the more famous ones. I mean, you know you're a nerd when you can talk about specific problems from previous AP tests. I get that. But this one comes up once in a while because when kids came out of this AP test, 4 years ago, they were just like blown away. Like the potato problem, Mr. Wolf. How do we do the potato problem? What is going on? So we'll look at the famous or infamous potato problem. And see if we can make sense of it. At time t equals 0, a boiled potato is taken from a pot on the stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees Celsius. Internal temperature of the potato is greater than 27 for all times. The internal temperature of the potato can be modeled using this function. dH dt equals negative 1/4 H minus 27, where H is measured in degrees Celsius. And it doesn't say, but T is measured in, or maybe it says somewhere, T is time in minutes. And H of 0 equals 91. Right. They already told us this. They said the initial temperature is 91, so that they're just clarifying on that one. Part A. Write an equation for the tangent line to the graph of H at t equals 0. Use this equation to approximate the internal temperature of the potato at t equals 3. Okay, so what do we need to write in a tangent line? Or any line. Slope and a point. And it said a tangent line at t equals 0. So that means I need the slope at 0 and the point at 0. So our point would be 0, 91. Our slope, the m would be dH dt, the derivative, at 0, 91. slow down a little bit. You guys are writing frantically. I want you to write and think. So most of the time, I feel like when we have one of these problems, we have to take a derivative and then plug in and get the slope. Here, in some ways, it's easier because they gave us the derivative. I don't have to take a derivative. I have to use the derivative, but they gave it to me. So I don't need to take the derivative of this thing. I need to use the derivative and plug in. What's going in for h? 91. Oh, and this was no calculator. So I'm betting, hoping that the math works out reasonably nice since it's a no calculator question. See, 91 minus 27. You've got to go old school subtraction here if you need to. Maybe 64. And hey, you don't have to reduce. So actually, you could just leave it like this. You could just plug that whole thing in for the slope if you really don't want to mess with it. But they've sort of rigged it to work out. 64 divided by 4 is 16. So they, again, on no calculator stuff, they usually make, if you have to do some computations, they make it so that it's possible. So y minus y1 equals slope times x minus x1. Now, I need to be careful because that's in y's and x's, and my equation is in h's and t's. So I either need to tell them what y and x are, or I need to switch to h and t. And it doesn't matter which one you do. If you want to use y and x the rest of the way, you can. You just have to tell them somewhere that you're going to set y represents h, and x represents t. So as I have it now, I'm not going to get full credit because, well, what's y and what's x? I'm going to just switch it to h and t so I don't have to keep up with it. Switch it back to h and t maybe. Write an equation for the tangent line. Okay, so there's my tangent line equation. I don't have to solve it for anything. That's an acceptable equation of a line. Use this approximation to approximate the internal temperature of the potato at time 3. So we'll plug in 3 for t and see what we get. So h equals negative 16 times 3 plus 91. I don't want to mess up the math. I don't have a calculator for this problem. I'll leave it as is. I mean, it's not hard, but why bother with it? Just leave it alone. Question B. Use the second derivative. Of course, we don't have the second derivative, but use the second derivative to determine whether your answer in part A is an underestimate or overestimate of the internal temperature at time 3. Okay, so overestimate, underestimate has to do with whether we're concave up or concave down. Well, before I get there, I need to figure out what the second derivative is. Well, I have the first derivative. I'm just going to copy it down again. So if I take a derivative of the first derivative, I'll have the second derivative. So taking a derivative, the left-hand side's easy. That's just second derivative. That's what we want. And then the derivative of this would be, let's see, negative 1/4. You know what? Maybe it might be easier to multiply it out. Negative 1/4 h plus 27 over 4. Because when I take the derivative of 27 over 4, it goes away. I don't have to worry about it. So negative 1/4 dH dt. But we have dH dt. So negative 1/4 times negative 1/4 h minus 27. So the second derivative is 1/16 h minus 27 and they said something about h is always greater than 27, which kind of seemed weird at the time, but now I know why they said that. If h is always greater than 27, what do we know about the second derivative? It's always going to be positive, right? Something minus 27, or 28 minus 27, or 40 minus 27. So the second derivative is always positive, which means h is always concave up. So I'm trying to get a picture of what's going on here. We're at 0, we're at 91. At 3, we think that it's whatever that was. I think from just the context of the problem, the potato is decreasing in temperature because we took it out of boiling water. Also, maybe we should have said this. H is always decreasing because dH dt is always negative. So I'm decreasing concave up. So decreasing but concave up. So something like that. And that makes sense. That's what a temperature does when you take something out of the oven. So we use the tangent line to guess what was happening at t equals 3. So was our guess an overestimate or an underestimate? Careful, our guess was the red because the tangent line. Your answer in part A. So part A answer, which I guess we should say negative 16 times 3 plus 91, is an underestimate. Because H is decreasing and concave up. This is definitely one of the harder free response questions. The potato problem. Part C, for T greater than 10, an alternate model for the internal temperature of the potato at time T is modeled by this. dG dt is negative G minus 27 to the 2/3. Find an expression for G of T. What is the internal temperature of the potato at time 3? Find an expression for G. Okay, so I actually have to solve this one for G. It would be an antiderivative. Before I take an antiderivative, I need to separate the variables to get all the G's on one side and all the T's on the other. side the negative's on, but it's probably easier to put it on the right. I guess leave it on the right. And yes, we'll integrate. Although integrating with a power in the denominator is a dangerous proposition, so I'm going to just rewrite that. As g minus 27 to the negative 2/3. That way I can do the power rule. So increase the power by 1. Divide by the new power. Plus c, but I'm going to put the plus c on the other side, equals negative t plus c. Let me reread the question here. Find an expression for g of t. That means I need to get g by itself. So I need to start to move things around to get g by itself. So I'll divide by 3. At some point I need to figure out what c is equal to. I can do that now, or I can do it later. It doesn't really matter. G of 0 is 91. That's what I'll use. Again, I could use it. It doesn't matter. I could use it initially, or I can solve for g and then do it. The algebra steps are going to be the same either way. All right, how do we get rid of this 1/3 thing? Cube it. So g minus 27 is, I'm going to switch those to c minus t over 3 cubed, and then add 27 to the other side. Thank you. All right, g of 0 equals 91. So we'll plug in 0 for t, 91 for g, and solve for c. I don't have a calculator, so I'm sure hoping this is all going to work out okay. 91 minus 27, we did that already. That was 64. Cube root both sides. What's the cube root of 64? 4. So yeah, they were nice to us in this problem, because we don't have a calculator, but they've rigged it so that all the computations work out okay. So c equals 12. So that means g of t equals 12 minus t over 3 cubed plus 27. So that's one of my answers. I don't have to box it. Maybe you want to underline it to kind of draw their attention to, that's one of my answers. Based on this model, what is the internal temperature of the potato at time 3? Okay, well if you make it that far, that's easy. Just plug in 3 and hope that this works. Well, actually, done, right? Why don't mess with the algebra of that. I suppose if you're curious how it compares to the other model, you could find it. 9 divided by 3 is 3. 12 minus 3 is 9. Divided by 3 is 3.
Oh, 12 minus 3, my bad.
Yeah, there you go. 3 cubed is 27. 27 plus 27 is 54. The other option was, we never even found it. We just left it alone. 91 minus 48 would be 43. So G of 3 equals 54. That was a heck of a problem that year. Hopefully you can make enough sense of it to at least get part A. I didn't print out the scoring rubric on this one, but it might have been 3, 3, and 3. So hopefully you could get 3 points for part A, and then it got crazy after that. But this would be one where hopefully you got 7 or 8 points on a different one, and you scrape out a few points on this one to stay in the game. Let's look at number 2. From 2016. All right. This one would not have been on the A/B test because we don't do Euler's method. So if we'll just throw out part D and we can do the rest of it. So for us, throw out part D. And while I'm thinking about it, I need to say this again later for our video friends, but flip it over when you're trying number 4. You can throw out part B because we don't have to do Euler's method. That's a BC topic. But the rest of the problem we can do. And Euler's method really isn't that hard. It's just we don't have time to get to everything. We got to throw some stuff out.
Wait, what did you say to throw out?
4 part B.
Okay, and what else?
2 part D. So number 2 part D and number 4 part D. Because we don't know Euler's method. If you watch the movie Hidden Figures, they mention Euler's method in there, just like briefly, and most of the people don't know what they're talking about. But if you've had calculus, second semester calculus or second year calculus, maybe your ear hears that and you know what they're talking about. Number 2. So they give us a dy dx. My initial reaction is that's not good because I can't separate those, right? I mean, I could add 1/2 y over, but then I'm not going to be able to solve this thing normal way, so I hope they don't ask me to do that. Part A is find the second derivative in terms of x and y. Okay, well, I can do that. So we'll take a derivative of the derivative. So the derivative of x squared is 2x. What's the derivative of 1/2 y? I already got the minus sign, but what's the derivative of 1/2 y? 1/2 just y prime or dy dx, either one. 1/2 dy dx or y prime, either one.
But it asks for it in terms of x and y.
Yes, exactly right.
So you got to put the original equation where dy dx is.
Correct. It says in terms of x and y. So this isn't really wrong. We just haven't answered the question yet. So I need to put this in for dy dx because it specifically said in terms of x and y. So it's not hard. It's just a little bit of algebra. In fact, you don't, safe stop. You don't have to distribute. You can just leave it like that.
When is it that you would have to do the y times y prime?
So if you were doing that's a good question. Why is it not y times y prime? If you were doing the derivative of y squared, so that would be 2y times y prime. chain rule. This is the chain rule too. The derivative of y is 1. Well, no. But the chain rule is, don't forget y prime. Yes, no? Still yuck. The derivative of 4y would be 4 times y prime. All right, but we're done with A. We can clean that up if we wanted to, and maybe we'll need to later, but for now, it's in terms of x and y. It doesn't have to be cleaned up, it just needs to be in terms of x and y. Part B. Let y equals f of x be the particular solution to that differential equation whose graph passes through the point negative 2, 8. I sense a tangent line coming on because they just gave me a point. And we've got a derivative, so who knows. Does the graph of f have a relative minimum, a relative maximum, or neither? Relative min, max, or neither at negative 2, 8. Justify your answer. Well, let's justify our answer first so we know what we're looking for. What's going on at a relative max? How would we know we have a... Okay. Wait. Other way. Oh, I'm sorry. I think I said max and you answered min because min is first. F prime changes negative to positive. Relative max, f prime changes the other way, positive to negative. So I'm thinking number line for f prime, and we want to know what's happening at negative 2, 8. But there's a trick here. I guess we could find dy dx at negative 2, 8. Let's do that first. So the first derivative is 0. That means there's a critical point at negative 2, 8. So I'm on alert that something's going on at negative 2, 8 because the derivative is 0. So it's probably not neither. Although it could still be neither because you could have a minimum, a maximum, but you could also have something like that where it's flat for a moment, but then it keeps increasing or keeps decreasing. So I don't know yet. Changes negative to positive, positive to negative. This is tricky because if you want to check on either side on a number line, I don't know the y values there. So I can't really do a first derivative test because I don't know. Right, my first derivative is given in terms of x and y, but I've only got x's, so I can't do this number line test of increasing, decreasing. So, yeah, this is true, but it's unhelpful for this problem. It doesn't help me, it doesn't work. Is there another way to talk about mins and maxes? Look at those two pictures. And think about what they already ask us for. Okay, they ask us for the second derivative. How can the second derivative tell us maxes and mins? Concave up, concave down. So if we already know it has a slope of 0. If I can figure out if it's concave up or concave down, then I'll know if it's a max or a min, or neither, if it's a point of inflection. So let's do the second derivative, called the second derivative test, at negative 2, 8. And we already have the second derivative, 2 times x minus 1/2 times x squared minus 1/2 y. And I mean, I can't really safe stop that because I need to know if it's positive or negative. So I could safe stop it earlier, but I can't really get around it here because I need to know if we're concave up or concave down. So a little bit of work here. But as usual, on the no calculator part of a test, it's kind of rigged. Like you start plugging things in thinking, oh man, look at the algebra I'm going to have to do. And 4 minus 4 is 0. So the second derivative is just negative 4, which means we are concave down. So negative 2, 8 is a relative max. Why? What would you say there? How are you going to justify that? I mean, how do we know that that's a relative max? Because concave down, what did you say before that? It's not decreasing though. Decreasing concave down would look like that. That's not our case. Its first derivative is 0, and it's concave down. So we could say second derivative is negative. Or critical point and concave down. So like really emphasize that you know what you're talking about there. So that's called the second derivative test, but you don't have to say it's the second derivative test. You just need to walk through your reasoning. It was flat, but concave down, so it had to be a relative max. Part C. Let y equals g of x be the particular solution given that g of negative 1 equals 2. Find the limit of this thing. Bet I know where this is going. Well, step 1 is plug in x and see what happens. So I plug in negative 1. G of negative 1 is 2. Okay, here's where we have to be careful. I don't really want to write equals 0 over 0 because that's not true. I want to somehow say that it's 0 over 0. The top is 0 and the bottom is 0. So this is the indeterminate form. Therefore, I'll use L'Hopital's rule. There was I don't remember if I saved it or not, but this was again discussed in my favorite calculus group on Facebook. I'm only in one calculus group on Facebook, by the way. I meant to take a screenshot of it, but I don't know if I did or not. Because somebody asked this question and can't find it. Oh well. But it was basically like, what exactly do I need to show here? And the guy again said, don't say that equals 0 over 0 because that's not okay. You need to do something like this. The top is 0, the bottom is 0, it's indeterminate, which means now let's take a derivative. So that would be g prime of x, which we have. That's how this problem started. They gave us the derivative. And then the bottom would be, let's see, 3 times 2 would be 6, x plus 1 to the first. Uh-oh, is this going to be indeterminate as well? G prime, that was way at the beginning, is x squared minus 1/2 y. So that at -1, 2. Let's see, that would be 1 minus half of 2 is 0. And again, they're keeping the computations easy because it's no calculator. So yes, we got to do a little bit of math, but they've made the numbers work out. So the top is 0, the bottom is 0. This took some work to make this indeterminate for both for 2 times in a row. Limit as x approaches -1. Second derivative. And then the bottom, the derivative of 6x plus 6 would just be 6. So that's good because now I know this is not going to be indeterminate because 6 is at the bottom. So the second derivative is, where did we go? We had that somewhere. That was what we had to find earlier. 2x minus 1/2 x squared minus 1/2 y. We want to evaluate that at -1, 2. So that would be 2 times -1. We just did this part. This part is still 0. So the answer for the second derivative is -2. So this limit is -2/6. And just in some small way to stick it to the man, I'm not going to reduce. I did all the hard work. If you want to go one more step, that's on you. That's your passive-aggressive comment to the grader.
How would you get -2 by plugging in?
So I plugged in -1 there. 2 times -1 minus 1/2 x squared would be 1 minus half of 2.
It gets rid of the negative when you square it.
So all the second part becomes 0. So man, what a lovely little problem that was to try to muscle through. And then there was a part D, but that was for our BC friends, not for us. So your assignment on the free response part is 3 and 4, but make sure you omit, I mean you'd omit it anyway because you wouldn't know how to do it, 4B. You can throw that out because we don't know how to do that. But I think the rest of those problems you could do. So that would be pretty good practice. And then the other part of the assignment today, back up a little bit, especially for our friends at home, is the multiple choice questions. Oh, by the way, on the multiple choice questions, you can omit the first one because there's Euler's method again. Throw him out. We don't know Euler's method.